Okay, so let's start your interview.
Okay, sir.
Okay, for BARC.
Yes, sir.
Okay, for which subject you are giving the snap today?
Sir?
For which subject you are giving the snap today?
Electrical machine, sir.
Okay, good. So first of all, tell me that what is the definition of transformer?
Transformer is an device, is an magnetically coupled, electrically isolated device, sir, which is used for transmission, and basically it changes voltage levels on both ends, sir, like on primary and secondary.
Okay, so how many type of transformer depend upon the when I say power and size
Okay.
and cooling?
Okay, sir. Like based on power, like there are two types, sir: power transformer and distribution transformer. They have different uses, like they work on different voltage levels, and they have different uses. Based on cooling, sir, there are air cooled, oil cooled, and forced oil cooled, many such like that, sir. And that's it.
Okay, so draw the ideal transformer diagram.
Okay.
Draw it and show to me.
Yes, sir. Like
Yeah.
nothing. Like okay. Sir.
Okay. For the phasor.
Should I draw the phasor diagram of
Yeah.
transformer? Okay.
Yeah.
I have drawn.
Yeah, it is okay. And suppose if it should be for practical, then how could the phasor be different?
Okay, sir. Like okay.
Yeah, yeah.
Sir? I have drawn, like
Yeah.
almost I have completed it. 1 minute. Yes, sir, I've completed.
Yes. Okay. Yeah, that is good.
Okay.
Okay, suppose okay, if you have two similar transformer, write it down the rating of 250 kVA.
Okay, sir.
Okay, and we have to do the back-to-back method for testing.
Okay, sir.
Okay, with a wattmeter, one is having rating of 5 kilowatt and other having 7.5 kilowatt.
Another one having, sir?
One is having the 5 kilowatt and another one is having 7.5 kilowatt.
Okay, sir.
Okay, you have to find out the efficiency of a transformer.
Okay.
Okay, and its efficiency, you have to operate at 0.75 of the full load.
Okay.
Okay, and the power factor is 0.8. Just give me the approach. How could you give the, write it down and just send me the approach.
Okay, sir. Like this is wattmeter one is connected to primaries, sir. Primaries
Yeah,
of both
yeah,
transformer.
yeah.
This is
Mm.
connected to secondaries of both transformer.
Mm-hmm.
Yes, sir. Wattmeter one will give no load losses, sir.
Mm-hmm.
Whereas this one will give copper losses, sir, which depend on current, sir.
Mm-hmm.
Like wattmeter 2, which is connected to secondaries, will give copper losses, sir.
Mm-hmm.
And you have said that it's on 0.75, like 75% of full load. So
Mm-hmm.
for full load copper loss, we need wattmeter 2 reading by 0.75 whole square will give you full load copper losses. For each transformer, if we consider those two transformers to be identical, each no
Mm-hmm.
load losses would be this wattmeter reading by 2, sir. Even here, even in secondaries for copper losses also, we for each transformer we need to multiply by 0.5. And for as we know, full load copper loss and no load losses, we can find efficiency at any load, sir.
Okay, good.
Like, is my connectivity good, sir? Like,
Yeah,
is it?
yeah, it's good.
Okay, okay, sir.
Okay.
Mm.
Okay, so just give me the idea that for the parallel connection of the DC transformer.
Hello.
Yeah.
Sorry, sir. I just got a call and I got muted. Sorry.
Okay. First of all, tell me what is DC transformer?
Sir,
What is DC transformer?
Uh,
Either it is possible that we can supply the DC to a transformer.
actually, no, sir. No, sir. In order EMF to be, uh, in order to get EMF on both sides, there has to be some variation in time, sir. Like uh, flux variation should be there, sir, in order to get EMF on winding. So in
Okay.
DC, it is
Yeah.
in
Yeah.
DC.
If suppose we apply the DC to the primary of a transformer, then
Uh,
what would happen?
like that depends upon the amount of DC voltage you are giving, sir.
Mm-hmm.
Mostly the current would be VDC by R1, sir, like resistance of winding.
Mm-hmm.
If this current is greater than full load,
Mm-hmm.
then windings may get burned. If it is less than full load, uh, no no voltages will come on secondaries, and literally it will be short circuit, sir. Like just current will be flowing. That's it. sir. Hello. Hello, sir. Can you hear me? Hello.
Yeah.
Sir. Can you hear me, sir?
Yeah, I can hear you.
Okay. Okay.
Okay. So, what are the conditions for the parallel operation of a transformer?
Sir, first of all, for parallel operation, secondary voltages should be similar to both transformers, and we need to also check polarity of two winding, secondary winding, and in terms of three-phase windings, we need to even check whether two vector groups are compatible or not.
Okay. Okay. So coming to the connection of a transformer, if suppose we have to 3 to 6 pulse transformer.
Sir?
We have 3 to 6 pulse transformer.
Okay, sir.
Okay.
Like,
Okay. So for the three phase, yeah. Hello.
hello, sir. Hello. Hello, sir.
Yeah. Now it is okay, na?
Yes, sir. Yes, sir.
Okay. Okay. Do the camera front. Okay. So. Okay. So can you tell me what are the schemes for using for the three pulse converter?
Sir, I can't hear you. Hello. Hello. Hello.
Yeah. Now I'm audible.
Yes, sir. You're audible.
Okay. So just tell me that what are the possible schemes for converting the three phase to six phase transformation?
Phase to 6 phase, sir.
Mm-hmm.
Okay. Like one of the schemes I have
Just
written down, sir. Like,
okay. Okay. So just I'm taking the example for the double start connection.
for
For the double star connection,
Yes, sir.
For the double ester connection,
Yes, sir. Tell me.
and the second system is displaced by 60 degree. There is shift of 60 degree
Okay, sir. Between, sir?
between the two.
Okay.
Mm.
These two ends. These two ends, sir?
Yeah,
Okay.
this one, second one.
Okay.
So just draw me the phasor.
I didn't understand, sir.
Just draw the connection.
Okay. Of double star
Yeah.
transformer, sir.
Yeah.
Okay. Drawn, sir, like double star winding, but I don't know like whether we'll get 60 degrees phase difference between both ends.
Okay. So one thing, just tell me that why we need the phasor. Yeah, hello.
Sir, I can't hear. Hello, sir. Hello, sir. Hello.
Yeah, hello.
Hello, sir. Hello.
Yeah, is the network issue.
Uh, Mine is, I don't, maybe I'll switch to another Wi-Fi, sir. 1 minute.
No, it's okay. It's okay. Say, listen. Okay, so just give me the what are the application of a Scott connection?
Hello, sir.
Yeah.
Am I audible, sir? No?
Yeah, you're audible. Now your network is stable, no?
Yes, sir. Yes. I'll switch to another Wi-Fi. Maybe it will work.
Okay.
Okay.
Okay. So just give me the example. Why we are mostly considering the phasor.
Your voice is getting stuck, sir. Like I can't hear some glitch.
Okay. So why we are mostly more focused on the phasor? What is the important of this?
Phaser like uh, Phaser gives like uh, it gives a basic understanding of any device, any electrical device, sir. Like it gives whether currents are lagging or leading, or the amount of current each electrical transformer is consuming for different type of loads. Like it's an basic things for analysis.
Okay. What are the application of a Scott connection?
Scott connection basically is used for conversion of three phase to two phase, sir. In olden days they used to they use two-phase induction machines, sir.
Okay.
And that's why they use the Scott connection, sir, for conversion of three-phase to two-phase.
Okay. So coming to the DC machine.
Yes, sir.
Okay. So give me the idea about the stator and the rotor. That what are the component in the stator and what are the component to the rotor?
Okay, sir. Uh,
Mm.
in stator, mostly field poles are kept, sir. They have windings are wound such that field poles can be present, and stator has a few another windings also, such as compensating windings and few small poles such as interpoles to tackle armature reaction. Whereas rotor has uh, conductors which carry actual power into the machine or out of machine. Uh, it has it has slots, and also at end of it, it has commutator for like for inversion or rectification.
Okay. So the material used for the stator, it is used for, okay, for the steel. There is a portion of silicon also.
Yes, sir.
Okay. So can you tell me what are the percentage of silicon impurity?
Around 5%, sir. Around 3 to 5%, as much I think.
Okay. So in the armature periphery, we are using the slotted.
Yes, sir.
Okay. So there are three type of slot based on the construction. Can you name them?
Yes, sir. Open, semi-closed, and closed, sir.
Okay. In the three of them, which having the highest leakage reactance?
Closed, sir.
Okay. And which is the best?
Like it depends upon like which machine are you using, sir. Like if we are using W-fed machines such as DC machines or synchronous machines, we prefer open slot. Whereas in induction machines, we prefer semi-closed or closed. Sir. Yes, sir.
Okay. Okay. Suppose there is a tendency of not starting this the series generator, so we are using the voltage build-up technique.
Yes, sir.
So what is this voltage build-up? And what is the value of the and what is the value of the resistance?
Yes, sir. Like you are asking about critical resistance, sir.
Yeah, critical resistance.
Like critical resistance is an resistance above which like this voltage build-up can't be done, sir. Like field winding should be less than critical resistance for voltage build-up, sir. Actually, like it is uh, this critical resistance is tangent to OCC characteristics of self-excited shunt generator. Like they and like mostly this buildup is done in phenomenon happens in self-excited DC shunt motor. Since since its field is not externally excited, uh, the EMF buildup, the EMF which is built up in armature only should excite the field, sir. So at starting, due to you return to field, some current flows through windings and it produces some voltage. Again, that voltage will produce another current. Like this, it will build up like till this point. Like, yeah.
Okay. Okay. What is the method of reducing the armature reaction?
Sir,
What are the method for reducing the armature reaction?
mostly we use interpoles and compensating windings. Sir. From a structural point of view, we employ chamfered poles to reduce armature reaction.
Okay. And what exactly is pole chamfering?
Kind of the one which we usually like this one's rotor, sir. Like whereas in usual machines uh, for uh, for constant flux density we use this kind of structure, sir. But in Stamford, like we use where where uh, uh, air gap increases as we go away from interpolar axis.
Okay. And what is exactly pole stacking?
Sir,
Pole stacking.
pole sagging, sir. Like, can you give a hint, sir, about pole sagging? Like, I can't.
No, it is a method for reducing the armature reaction.
Okay. Pole sagging, sir.
Mm-hmm.
No, sir. I don't know about that.
Okay. So, what exactly the interpol compensate rewinding do, and
In,
how is the shifting? Yeah, how is the shifting take place?
yes, sir. In any machines, like apart from main field flux, even armature conductors produce a pole pair, sir. This
Mm-hmm.
distorts main field flux and
Draw the diagram.
yes, sir. Uh, let's say if it's a generator, sir.
Mm-hmm.
Here dots will come, sir. Like this is this will be the direction of induced DMF, sir. If load is
Mm-hmm.
connected in same
Mm-hmm.
direction, current will flow, sir. Like due to as currents flow in armature, the rotor also develops a pole pair, sir. Like by using right hand rule, we know that here. So the main field flux is in this direction, and the armature flux is in this direction. So they obviously they both interact and produce an resultant, sir.
Okay, good. So, what is brush shift? Why do we shift the brush?
Actually, since the resultant air gap flux has been distorted in this way, what
Mm-hmm.
if we don't change brushes like
Mm-hmm.
commutator brushes, Here still it is not an interpolar axis anymore, because there's still few flux, like a resultant flux even flows through this axis, due to which where brushes are kept, windings will be shorted for commutation process. If if flux, if some kind of flux density is present there, the coil in which is short circuited, currents will flow through it and damage the brushes. Whereas to tackle that problem, what we do is we shift the brushes according to resultant armature flux, such that there's no damage to the brushes.
Okay. And what are the disadvantages of brush shift?
Like the armature reaction depends upon the amount of current flows. As the load changes, you need to also shift the brush. So it's a continuous process. For full load, if we shift the brush, for no load, there might be some sparking. So brush shift depends upon amount of load that a machine is carrying.
Okay. And does it cause the demagnetization?
Yes, sir. It causes demagnetization, sir. Like it causes, yes, sir, it causes demagnetization.
Yeah, good. Okay, so your interview is over. I'm giving you the feedback.
Okay, sir. Like, could you even ask in synchronous or induction machine, sir, if you don't mind?
Yeah, one by one, but the time is over, so I have to give the time to. Okay.
Like, okay, fine. Like tomorrow, will you take induction and synchronous machine, sir?
Yeah, actually, I just cover the DC and transformer only today because I have to go in the depth now. That's why.
Okay. Okay. Tomorrow, will you take, sir, for induction and synchronous?
Yeah.
Okay. Thank you.
Okay, so you have the good knowledge of the machine, and all the question that I've asked about the phasor, thereafter the one numerical, and and the phase notation, and one thing that I've asked about the phasor, that
Yes, sir.
suppose there is a star connection and there is a phase shift of 60 degree in the one transformer, then how the resultant should be drawn.
Yes, sir.
Okay, so see, you have also studied in the transformer that for the phasor to be balanced, we are there is also called there is also called the phasor. Okay, so there is also technique like ASA technique, and for which A1 A2 we taking the primary of the transformer as A1 A2. Thereafter, depending upon the requirement, we do the shifting of the transformer, and phasor shifting should be optimum. Suppose we have a double star connection, and so there are mostly 3 or 4 method. Okay, for converting three phase to 6 phase transformation, mainly double star, double delta, 6 phase star, and dimetric.
Okay.
Yes,
sir. I'll read about this, sir.
Yeah, in the double star, suppose one we denote as A1 B1 C1, and another with A2 B2 C2, and thereafter the second star should be of A4 B4 C4, and thereafter A3 B3 C3. And while we draw it, and thereafter we do the shifting by some angle, star or star delta. So the resultant should be drawn as we are shifting and take the reference from the one. So it is drawn in that way. Okay.
Sir, I have one more doubt. Like in double star, we'll get a phase shift of 0 or 180, no, sir?
Yeah, it
0
is 0.
degrees or
Yeah, it is 0, but I have given you the some condition that if you shift the one by the 60 degree, then what would actually the comes.
okay, sir.
Okay, these are the assumption.
Okay. And also, sir,
And
pole tapping you have told, no, sir?
pole tap.
Can you explain it in little bit, sir, so that I can understand?
Yeah, so there are 3 or 4 methods: pole sampling and pole stacking, not tapping, stacking.
Okay. Okay. Sure.
Okay, so we cut the core of the pole in the half, and thereafter we laminate it and then reconnect it. This is known as
Okay.
pole stacking.
Okay. It increases armature, like air gap reluctance, sir.
Yeah.
Like, okay.
Any any more question?
Nothing, sir.
Okay, please go through the phasor of the transformer. Okay, phase delta star star.
And also, sir, you asked about 3 to 6 phase transformer, na, sir?
Conversion. That is what I have said, na. There are 3
yes,
or 4 methods. There are
okay,
3 or
like
4 methods.
what I have drawn is the correct answer, sir? Like this one.
Yeah, that is correct.
Okay.